part of wave nature of light. Light behavior through different media. Media are classified according to ability to allow light to pass through it into transparent media, translucent media, and opaque media. What's the difference between transparent or translucent or opaque medium? Transparent medium like a glass, air, water. Glass, air, water, all of them medium, glass medium or air medium or water medium, all this media allow most light to pass through it. So the meaning of transparent media, the media that allow most light to pass through it. What about translucent media? Translucent medium like frosted glass or tissue paper. Frosted glass or tissue paper allow some light to pass through it. So it allows some light to pass through it and absorb the other parts. What about opaque medium? Opaque medium like material, wood, metals, carton, all of them don't allow any light to pass through them. So we classified the material according to transmit light into transparent, translucent, and opaque. Transparent allow most light to pass, translucent allow some light to pass through them, and opaque medium don't allow any light to pass through them. Now, give reason we can't see impurities in black honey. Why we can't see impurities in the black honey? We can't see any object or anything that is fall in black honey because the black honey is opaque medium, so it doesn't allow any light to pass through it. The fifth property about light travel in a straight line. You know that light travels in straight lines, not zigzag line, not curved lines, not zigzag line or curved lines, but light travels in straight lines, and its thickness can be controlled. I can control its thickness to be wide or to be small. Let us talk about another property for light intensity or brightness. As you know, if you have light and you fall light on something like board, as distance increase, what will happen? If the distance increase, what will happen to light intensity? Light intensity will be decreased. Okay? So as distance increases, light intensity will be decreased, and vice versa. So when we do that, we find that the distance increases to double if the distance of the distance between a light intensity and our source of light and a board or screen that light falls in it to double, the distance increases to double. What will happen? We find that the light intensity decreases to quarter. So there is inversely proportional between light intensity and the square of distance. If a distance 1, we find that this light intensity equal 1. If distance increases to double, light intensity decreases to quarter. So we find that light intensity is inversely proportional to the square of distance. As you see, if we draw a relation between light intensity and the square of distance, we will find the relation is inversely. From here, we put the inverse square law of light. The inverse square law of light states that light intensity is inversely proportional to square of distance between surface and source of light. Give reason here. The light intensity of light increases 4 times. Intensity will increases 4 times when a distance decreases to half. Why? Intensity will be increases 4 times when distance decreases to half, because light intensity is inversely proportional to the square of distance. Because light intensity is inversely proportional to the square of distance. So the meaning of light intensity is the quantity or the amount of light falling perpendicular to unit area in 1 second. Here, if you want to measure the light intensity, you'll count the amount of light that falls perpendicular on unit area in 1 second. Now, if you have wall like this, and the light intensity here perpendicular is equal, the light intensity here equal 2, and the light intensity here equal 4. Which one has high value? Yes, this light intensity here is more than light intensity here, because the amount of light that falls perpendicular in unit area in this area is more than the amount of light or the quantity of light that falls on this unit area. Thank you.